So I'm Elena. I'm doing my PhD at the University of Gothenburg in Sweden, but I'm from Spain. And I'll be talking about thermal tolerance and acclimation capacity of two pipefishes under a simulated heat wave. In particular about Signatus typhle and Nerophis ophidion. In general, my PhD is about impacts of warming on fish communities on seagrass beds. So I'm not a specialist on Signatids, but I have them included in my thesis. This is where I work. I work at Kristineberg Marine Research Station in Sweden. This is quite far away from here. If you see we are here, and about 4,000 kilometers up north, that's where Kristineberg sits. And it's quite a beautiful place. It's in this fjord called the Gullström fjord. And yeah, it's beautiful, but it doesn't look like this at the moment. It's actually looking like this. It's all frozen. And it's quite convenient to work there because we have Zostera marina growing just outside, so that's where I collected my fish. And so in Sweden, in the west coast, we have about 35 species associated with Zostera. They're mostly juvenile codfish and flatfish, and also some coastal species like wrasses, gobies, and sticklebacks. And then we have 5 species of Signatids. So we have Accus, Rostellatus, Typhle, Nerophis ophidion, and Entellurus aquarius. Like everywhere else, the fjord is warming. This is satellite data that I plotted for Kristineberg for the last 40 years. So you can see that we have a warming trend since the 80s. On the mean summer temperature. But even if you cannot maybe imagine, we also have heat waves in Sweden, and the number of marine heat waves and the intensity has also increased. Fish have to cope with these extreme events somehow, so they have 2 main strategies. One is to try to acclimate by doing physiological adjustments. And if they cannot handle it, then they will try to escape to cooler waters. So we have a range of temperatures where fish can perform well, that can grow and reproduce, but on the colder end and in the warmer end, we have temperatures where they can only stay for a limited amount of time, otherwise they feel stress. And if they stay too long, they can die. I've been mostly focusing on this point. This is the critical thermal maximum. So if they stay too long there, they might lose motor control and they can no longer escape heat. So the main research question was, do Signatus typhle and Nerophis ophidion have different thermal tolerance and also different capacity to acclimate to heat waves based on measurements of Ctmax? So the hypothesis was that if I measure Ctmax under the ambient conditions, because they are different species, maybe they have a different Ctmax. But if I expose them to a simulated heat wave, if they acclimate, the Ctmax point will increase in this line because they will have some phenotypic plasticity. And also, because they are different species, they might also have a different magnitude of this increase. So I had a lab experiment. I had for each species, I had 10 tanks, 5 at 19 degrees, which is our summer temperatures, and 5 at 23 degrees, which is what is considered a heat wave locally. And then we had flow through seawater from the fjord constantly, and the room was regulated. And then we had about 15 fish per treatment, although we lost some typhles. And we exposed the fish for 5 days, and then we measured Ctmax. So it was quite straightforward design. And how do we measure Ctmax? So this is a behavioral response. So it's the temperature and when they lose the equilibrium and they can no longer right themselves. So basically they sort of pass out like in the sauna. There's a lot of literature on how to measure this properly, but it's also quite affordable equipment. So you just need a box. Yeah. You need a box, you need seawater, then you need a heater, a pump, and a thermometer. And you separate the instruments from the fish, and you have your experimental tank, the fish on your tank, they become one CityMax test. So if you had 5 tanks, you get 5 replicated tests. And what you do is you slowly increase the temperature of the water with the heater, and you have one person observing the fish, and then one other person controlling the thermometer, so it's blinded. So the person only observing the fish has a little brush that sometimes you poke them, and when they can no longer right themselves, that's CityMax, that's LOE. So then they say, CityMax, or fish 1, and then the person writes the temperature that they see on the thermometer without being biased by what you expect from the fish. So it's a 2-person job. So this is the type of data you get. Fish 1 passed out at 32.1, etc. At the moment that they reach CityMax, we also take them out from the test and we put them at their original temperature. So after some minutes, they recover again and they just fine. So it's a non-lethal test as well. So these were the results. What you can see here is that the fish that I exposed to ambient temperatures, Signatus tifle had a higher CityMax. So tifle was more tolerant than Nerophis. But after exposing them to the heat wave, they reached more or less the same CityMax. So they had some kind of thermal healing, ceiling. But if you see the magnitude of the increase between CityMax at ambient and at heated, Nerophis increased it more. It increased it by 1.5 compared to 1 degree from tifle. So even if tifle was more heat tolerant from the start, Nerophis was more plastic, had greater capacity to increase the thermal tolerance. So you can see, you maybe are asking yourself, these temperatures are 33, 35 degrees. They don't experience this in the wild. So what does CityMax really mean ecologically? So there is a paper by Sunday, there's also more literature that relates that fish that are, or ectotherms in general, that are at warmer temperatures, they have higher thermal limits. So you can use this measurement of CityMax as a proxy of their thermal tolerance that they can tolerate in the wild. Also, if you look at the maximum thermal ranges, here I looked in fish-based, I guess this is approximate from models. Tifle seems to be a higher thermal tolerant. That, it relates to the measurements that we did. Even if you can only see it's half a degree, but they seem to be, relate to what they are distributed. I was also looking at sea temperatures measured exactly at the lab for the last 30 years. This is decadal daily maximums. And you can see that each decade the temperatures are warming, but we are still about 19 to 20 degrees in the warmest season. So that means that even if sometimes the extremes get to 23, and that's why we had the heat wave, they still have a lot of room, right? So that's what Nuno was talking earlier, that fish are moving northwards because they still have a safe margin to live there. So it's for Sweden seems to be a positive story about cygnatids. I've been also looking in my PhD at abundant changes. I was revisiting eelgrass beds that had historical data and looking at the whole community, and we found that Nerophis has increased its density the last 20 years, but Tifle has maintained, more or less. And then I also saw that the most dominant is Tifle in Swedish seagrass, but Nerophis has increased a bit. So the conclusions is that about the physiology, Tifle is more heat tolerant than Ophidian. They both have certain plasticity because they both managed to increase this Citimax. But Ophidian had a greater capacity to acclimate. And then about the ecology, Tifle is the most common pipefish in Sweden, on Sweden's eelgrass meadows. Nerophis has increased its abundance the last 20 years, but they both have safe thermal margins to still live in warmer Swedish waters. As a curiosity, during my surveys, we found a seahorse that's rare in Sweden, and it got to the news. And we've also been seeing Sparit and this weaver here. So it seems that we can already see some warm water species coming there. If you are curious about how this Citimax story relates to other fishes, I have been measuring it also in other fishes on seagrass, like wrasses, for example. They were the most heat tolerant and caught the least, and so I have a preprint. And don't miss the talk of my colleague Ellen. She will talk about the 2 new eDNA assays for detecting seahorses. And also, Leon, in his poster, he will talk about northwards range expansions of seahorses in Sweden. And if you want to come to the lab I'm working, you're very welcome. There's funding for early career researchers, so I can give you some tips on how to go there, and the funding will cover the use of the infrastructure. And with this, I want to say thank you, and thank you for the opportunity to present here.